Students have come.
Hello, sir.
Sir?
Sir? Sir?
Students have come. Shall we start the class? Kumar, you can also, all of you can keep your video on so that it will be interactive for me. Right? Just without seeing face, no teaching is doesn't look nice. Keep your video on. I think we'll start the class. Let's join because already it is 5 o'clock, 5 for me in my watch.
Sir, we can start.
Let's start, sir.
Let video be on. Whenever you mic alone, you can mute it. Video let it be on so that at least it will be interactive. Other online class will be just like talking the old telephone. It's not meaningless. Okay. Shall we start? Okay, fine. Yesterday, I just start what we are talking yesterday, and by the time the other student joined, we know that we are talking about ABS for last 2-3 classes. We looked into this file. We know that if it's a good driver, correct, professional driver, for example, test driver or Formula One race driver, he will be able to control the slip within 5 to 15%. You can see that. That is where you are getting peak braking force. See here, wheel slip. Yeah, here you can see that the peak performance happens only here. Best braking force and best cornering force also. Correct. So still you are able to steer the vehicle. Cornering force is you are able to steer the vehicle. But when ABS, most of the ABS, they will try to maintain slip between 5% to 20, approximately 17, 15% or 20% within that range. Correct? You can see that ABS will maintain 5 to 20%. The best driver may be something around 7% to 15%. So that is best. That is optimal. That means a lot of, but ABS is okay. Then again, you can see here when you start applying braking force, ABS is not going to apply full force. That means this is locked condition. Full hydraulic pressure means wheel is locked. You can see that is this whole region wheel is locked. That means vehicle will skid. You should not operate this applying full braking force. Manually you cannot control, but ABS will try to apply braking force because we are talking in lots of milliseconds. Correct? We say that something around 20 millisecond to 50 millisecond, depending upon modulation frequency. Correct? Approximately. Please don't say that again. Sir, I saw one company, my company ABS is working at, for example, the 1000 here, this one, modulation. Correct? 1000 time braking and releasing per minute. Correct? So it can vary. I told you smooth performance you will get if you apply brake higher modulating frequency. Higher modulating frequency. What is the advantage? You see the apply brake for a small duration, release the brake. So the passenger or driver won't even know that the ABS is applying brake. But it every time it will do 1 RPM, 2 RPM of the wheel. Correct? 2000 times within a minute. So the vehicle will never get locked. This region is avoided. That's what we want to learn. So if hydraulic fully applied, the brake will maximum force and wheel will lock. We don't want this at all. So that means we'll operate within this region only. You can see the difference between the vehicle speed and wheel speed, correct? So this is the difference between any instant. During instant, you can see very small, correct? Let me clear this. You can see that as long as wheel is not rotating, this is stop rotating. That means skidding happens, correct? So that before that, the braking force applied, hydraulic fluid pressure applied is less. But when you are doing, you can see that any given instant, this is the delta speed. Delta speed, that is vehicle speed is higher, wheel speed is lesser, correct? So as you apply more braking force, this increases, but we'll see that the speed difference. What is the higher the speed difference advantage? Quickly vehicle come to a stopping, correct? If your wheel slip is very less, it takes longer time to stop the vehicle. Wheel slip is higher is better. How much it is better? Up to 20%. That's what we are saying. So any given time, this will be the difference between the delta speed difference between vehicle speed and wheel speed. So you'll be operating. What I'm trying to say is the ABS, this difference in the vehicle wheel speed is only very small, few RPM, correct? When we talk about this one, so slowly apply, release, apply, release. So a smooth braking happens without skidding. Okay. Now already we talked about it. Again, I introduced what are the input. This is the ABS control software. We are running in the ECU. What are the input it is receiving? Brake pedal switch, correct? In ABS, actually, you are not applying any mechanical link. There's a brake under your brake pedal, correct? Under your brake pedal, you may have a switch also, correct? A switch which says ECU that driver has applied. You press it. You apply it gently or hard. In ABS system, it doesn't matter. Since you don't have any control, brake force, you don't have control. It is controlled by ABS ECU by controlling the brake shoes using hydraulic system. Right? So that means even a new driver, due to panic, when the wheel get locked, correct? You know the experienced Formula One race driver, they don't use ABS and all because there are many limitations in Formula One. Correct? You should be manually control all the. Then only see their whole idea is see how good driver is. Correct? Best driver in your formula, not only vehicles. Correct? So many automation they remove. Then only the driver show his capability. So that's what we show the best. This one driver he will maintain within. See the expert driver or Formula One driver can maintain slip within this range where the braking force is maximum without wheel get locked, but quickly comes to a stop. Smooth stopping all this without skidding. So now that means when driver you press this one, even a Navy driver, correct? That means he doesn't know the experience. When he sees something, you know that I told you, if you are a new driver learning car, even if we see a obstacle, 500 meters, you will immediately apply brake. Correct? We don't know about how to control that is this one till you learn. Correct? So even if you press, nothing happens because the braking is controlled by ABS ECU. This ECU is going to generate. Then what else is there? This is the braking input by the driver. Only when driver press a brake pedal, the switch closes, ECU know that it has to apply brake. Otherwise, you won't apply. ABS will not come into picture at all. Because you don't want to apply brake unnecessarily. You'll be wasting energy, all those things. So once you press this, then what ECU will see, it will measure the wheel speed, individual wheel speed using individual wheel speed sensor. What is current speed of individual wheel? Correct? It will also measure lateral acceleration. This is the vehicle speed. Lateral acceleration is nothing but vehicle. Then pump. There's a pressurizing fluid pressure is there. No, we know that it is a hydraulic system. This pressure has to be maintained. Correct? So the fuel, we saw that. Yeah. The pressure, correct? The pressure has to be maintained. The pump, that is, this motor is controlled so that the pressure of the fluid is maintained. Maybe 50 bar, 20 bar, depending on what is braking force in it. So a constant pressure should be maintained by switching on this motor. Correct? This motor is controlled by ECU. Correct? And this is pump with such the fluid and pressurization keeps in this one before the valve A. So whenever you apply brake, the pressure fluid comes out. Constant pressure should be maintained. That is done by controlling this. These are the jobs of the ECU. Right? Then a solenoid monitor is there. Then if brake fluid can leak, correct? Brake fluid can leak to in the this wherever joints, all those things. So that also should be monitored. How you will monitor? By measuring the fluid pressure itself, you can monitor. Correct? If frequently fluid pressure is dropping, there is some leakage is there. This one. Then of course a power supply battery to the ECU, which is going to this one. Then ignition switch. Correct? Whether engine is on, then only brake should come. The automotive power comes. This is ground. Then what is output? These are inputs. These are input to the ABS controller. Brake switch. That means it knows whether when the driver is applying brake. There's one input. Wheel speed input. Accelerator. This one. Pump monitor whether pump is running. Correct? Which pump? The fluid pressure pump. Then solenoid monitor. Then fluid level. You can put fluid level also, but this one. Upper what output? Individual solenoid control, because this each one wheel has a ABS, that hydraulic this one, disc brake. Correct? So by controlling this one is there for each wheel. Please note that this is there for each wheel. Each wheel, there's a wheel, associated valve, until like this. There are 4 things for 4 valve. It is there. These valves are controlled. Right? These valves are controlled. That's what we are talking here. Solenoid valve, that is A valve and C valve. A is the this one opening. If A open, brake applied. If C open, brake is released. The fluid pressure released. Correct? So the combined 4 valves are controlled. Then a pump relay, like a valve solenoid, because you have to switch on this pump. So because this is electronically controlled, you are not going to control. It is kind of fluid pressure, everything switching on the pump. Which pump? This pump switching on and switching off will be done by ECU. That is done by ECU. That's correct. This pipe, only when the pressure drops, that time the pump will be on. Unnecessarily you will not run the pump. Correct? It is an electric pump. Can be electric pump. The electric motor, unnecessarily or battery power you are draining. You should not waste pump. Only when the pressure drops, by monitoring the pressure, and you switch on the pump. That is also controlled by ECU. That is the ECU job. Right? Then there's an indicator in the dashboard whether the ABS is active. You can that some of the cars you can deactivate ABS. Correct? Still there are some cars where you can apply manual also. Manual braking also available. You can deactivate ABS. Correct? Still possible. Then if it is active, how do you know? Dashboard may be a small indicator. Correct? If there is any error, fault condition, again one more one LED or some error in the code can be indicated as a number. So this will be there. Of course, this is data for sharing with other ECU. Suppose you wanted to fault diagnosis, there will be a serial data cable. You connect to this is ABS ECU, correct? That can be monitored. All those things you do. These are the different inputs comes to this. Okay. So inputs, and this is control outputs. So then this is power supply, ignition control, power supply ground. Okay. So already we talked about it. So this picture shows how the ABS works, flow chart. Please take the flow chart note down, because the exam you may ask how the ABS works. You have to show the flow chart. Apart from writing, the flow chart you have to draw ABS parts, solenoid valve. This all these diagrams, correct? These diagrams, how it works. These are things. Hand sketch. I'm not going to draw. Hand sketch you have to draw. And now coming back here, now we know that this is algorithm. Basically, you can write in C, Python, programming language can be anything. This is algorithm which you can translate into a code and compile and store into the embedded controller inside your ECU. So every time, say the K means sample, right? I have sample at K time. What sample you measure? Then K plus 1. Well, now, first thing is you acquired the velocity of the vehicle, correct? V is the velocity in X direction, that is forward direction. COG, I told you in vehicle chassis, correct? You have a big chassis on which you have the front and back wheels, correct? In COG point, in vehicle chassis, main point is COG point, you install one accelerometer. That will measure the actual acceleration. By integrating, you can get the vehicle velocity. Vehicle speed is measured using this accelerometer sensor, which is installed on COG point of the vehicle and the chassis. Right? You know the all vehicle has a long chassis, right? On which only body is built. On which you put that you take this because you are going to measure kth sample, right? Every millisecond once the ECU can measure. Then what it next is, it finds, next thing is first acquire the what is current vehicle velocity using this sensor. Then it finds is the vehicle velocity is greater than 0. Right? What is the braking system job? Stopping the vehicle. When vehicle is stopped, this Vx is nothing. Vehicle velocity will become 0. If vehicle velocity already 0, where is the question of applying brake? Vehicle is not moving, right? So EC has to check. That's what you do, right? Suppose you start your vehicle, you are still in idle condition. Will you apply brake? You know that your vehicle is not moving. Why you have to apply brake? Right? You want there is unnecessary job. So ABS also, even if you press the, when vehicle is in neutral gear, if you press brake pedal, ABS should not be actuated. So ABS software first will first check whether vehicle is moving. And that means the vehicle velocity measures. If vehicle velocity is greater than 0, then only it has to go to next step. Otherwise, stop. Don't operate ABS. Unnecessarily applying braking also waste of energy. So ABS won't work. The vehicle is not moving, ABS, even if you press the brake pedal, it won't be activated. So it stops. If no vehicle is moving, that means you have to apply. Yes means vehicle is moving. Then what is the vehicle speed minimum? This one, V min, and what is the current speed? Current speed already you measured. Correct? Kth sample you have taken. What is the minimum speed with vehicle? Correct? So the once if this value is smaller than or equal to V min, right? Then what you have to do? You have to go acquire wheel speed. You have to apply get the wheel speed. Wheel speed already your sensor, wheel speed sensor is available. So you have measured vehicle speed here. Now at this condition you are getting wheel speed. WK means wheel speed. Wheel speed you measured at kth sample. Then you compute slip. Correct? You have to compute the slip. That means we know that vehicle speed minus wheel speed. Slip S equal to vehicle speed minus wheel speed. Already we know that. So that is computed here. Now then you are checking what is the slip value. Already we know that slip should be within 5 to 15%. You have to maintain. So that's why it's checking whether the current slip value is lesser than this 5% you have decided in your while programming in your company. The ABS you said 5% of wheel slip. Okay. Then if it is it equal to this one? Yes means correct. What you have to do? You have to go for braking. Correct? You should apply brake. That means the brake force, the A valve will be opened. This valve will be opened. Then brake is applied for some amount of fixed that depend upon what is the modulation frequency. I said if it is 1200 pulses per minute, that means 20 hertz. That means one modulation brake will applied for 1/20 is nothing but 50 millisecond duration. For 50 milliseconds, brake will be applied. The valve will be opened, brake is applied. So the vehicle speed is reducing. Okay, apply force. Otherwise, you check. Don't if you know the if it is greater than correct the current slip. This is the current slip. Correct. This is the current slip. You calculate a SK is the current slip. You are comparing. If otherwise no means what you have to do, you have to check what is higher value, whether S equal to S of K is right greater than equal to S max. S max is 15 already we said. We are checking. S means release the brake. Correct. If current slip is equal to greater than this one means you have to apply brake. Right? You have to increase slip. So the maximum braking force, you have to maintain 5 to 15%. For example, in your car, you are decided. For some other car, there's a 5 to 20%. They can decide. Why means that it depends on what type of tire, all this thing, algorithm, smoothness, all this thing. Many things are coming to picture. So the ABS algorithm checks. If it is already slip is greater than 15, you are decided to maintain 15. Brake should be released. So again comes back. So this is how it works. Note down this formula. This is a flow chart. This is the ABS working flow chart. So now this goes on. This is going on all these things till vehicle comes to 0. Correct? When vehicle speed is 0, correct? Then stop. the ABS algorithm stop. That means vehicle has come to stand. It was going 70 kilometers. It applied for 30 seconds or 1 minute, 2 minutes. Vehicle has come to standstill without skidding. Then vehicle stops. ABS algorithm stops. Okay.
Sir, how to measure a V minimum or set up V minimum? Like it will vary based on manufacturer.
The manufacturer decides. For each car, he decides.
Okay.
Okay. So now you have taken it, drawn the flow chart because exam it is expected. Please.
Professor, I have a question. I'm just like yesterday there was a topic of like you told that if we increase the modulation frequency of the ABS, the braking will be more effective.
Effective means smooth.
Smooth.
Not effective. It will be smooth.
I got the point. So basically, suppose a vehicle is having X mass and having a like what I mean to say is DR some fixed R value, and if I install modulation frequency of suppose 60 hertz or one is having 100 hertz, then how we plot how the like braking what I mean is stopping curve will look like, velocity reduction will look like in that way.
It will drop like this. The slope will become steeper and steeper.
So which is the better smooth better braking in the smooth braking in this among three?
See, that's what you have to see. Correct. The main thing is you apply a very small braking force every time, short duration, and then it will be smoother. Correct. So, but what will happen is you have to see the distance, how much time it takes.
Okay.
Correct. Because you need to calculate. But you have to plot current velocity, wheel velocity, you know the number of distance, how much distance you have traveled. Correct. When the speed is reducing, every time speed is reducing. At that instant, within this one, how many rotation wheel makes. From that, you know you can calculate the braking distance.
Okay. So, my question was a bit different. So, like among these three curve, which is having the which we call a smoother operation of brake.
Smoother operation, higher frequency always smoother. Correct.
So
your jerky movement is not there. No, you apply brake, stops. You won't feel higher in braking, but the incremental will be very, very small.
Okay.
Okay.
Fine.
Okay. Now the control system we are talking. This is a closed loop control system. Correct. So what we are seeing, whether wheel is stopped or not, we are monitoring with the wheel speed sensor. So to apply brake. So if you wanted to test your this one ABS without making actual system and testing an actual vehicle, you can do simulation. Simulation study is nothing but you build the vehicle model itself, correct, and develop the controller. That if I want to do this one, you need to find out the vehicle dynamics and wheel dynamics and ABS modulator and the controller, ABS controller. All those things you have to model. That's a mathematical equations. Correct? So now simplified model, this vehicle model is nothing but this. As per AB is concerned, vehicle has a mass, that is capital M, right? And it is accelerated. Vx dash means A. We know that F equal to ma. Newton's law. Very simple. That's what. The simplified model of your vehicle. Vehicle has some mass and it is with acceleration. Vx is vehicle speed. Vx dash is nothing but acceleration. This should be equal to, correct? This is because of who has given this. This is engine. Because of the F traction force generated by engine. Because of the only now currently it is moving with some acceleration. Correct? The acceleration not changing is a constant speed. So this is left side of equation. Right side, this is forward momentum because this is the forward moment is there. What is that opposes? The traction force on the four wheels. Ft, correct? Ft is the road frictional force, correct? Which acts against the motion. This fellow wanted to move the vehicle forward. This one and this one is moving backward. Fa is another aerodynamic drag. This is the frictional force between the 4 individual wheels. That's why you can say individual tire, F of T I. I varies from 0 to 4. That means individual 4 wheels. We are summing up the friction in the 4 wheels. And also aerodynamic, correct? Now this should be forces opposing the movement, forces opposing forward movement. Correct? This is the force for forward movements. This generated. So now we know that because now this is going to be dissipated because engine is not running. This force initially has some F into ma has some this one value. Once you stop accelerating, when you want to apply, you take your foot from the accelerator pedal. That means already whatever engine is given, many correct. That's what is going to be there. Then you are start applying the braking force. Then, but apart from braking, because vehicle is moving, there's aerodynamic drag also is there. That is proportional to velocity. How will you calculate aerodynamic drag? This one force that you can calculate using this. Correct? FA, aerodynamic force, which opposes the forward motion of this one. Please know aerodynamic drag helps you in applying brake. They are also assisting you in braking. And aerodynamic drag is opposite. Of course, when you want to go faster, you don't want. But while applying brake, it is going to help you. It is useful also. It is useful force. Apart from the braking force applied the wheel. You can calculate. This is density of that. This is a constant. CD is whatever aerodynamic coefficient. It is called as aerodynamic coefficient. We wanted to have, the sport. If we have a square front, your vehicle is like this, or a box type vehicle, we say, right? The vehicle is box type. This has the maximum error. The CD is maximum, close to 1. That is the worst design as the aerodynamic is concerned. But many times you will have all containers will have because we want maximum volume to keep maximum material you want to transport. Fancy styling, all the will not have you want to carry. So that means truck, all those things will have this kind of. Even bus also, you see, front will be like this only. Maybe a little bit smooth, all the styling, nothing more than. So this is CD will close to 1, but we don't want. Correct? If we want best fuel efficiency, correct? For forward motion, the CD should be smaller. They're called aerodynamic coefficient. If you take a sports car, Ferrari, correct, or race car, all those things, you will see that the very this one, this will be very, the coefficient will be very small, correct? This is A is called a frontal area. A is called a frontal area. This area, frontal area, this is coefficient particular shape. Whether shape is like this, shape is box-like things, or circular shape, correct? For example, engine may have circular shape also. For train engine, old generation train engine, boiler, all those things. So that is the area of this one, and multiplied by the coefficient, drag coefficient. Then most important, velocity square. Aerodynamic drag is always a velocity square is going to affect your vehicle. So this you can calculate. If for the particular design shape of the front of the vehicle, this one CD will be given. Then area also will be given. Then air density varies with respect to temperature and this one, correct? Altitude, all those things you can compute. Then only thing is vehicle velocity, correct? As vehicle velocity changes, automatically this will happen. The next one is plus the frictional road frictional force between tire and this one, that you can calculate. As yesterday Kumar was saying, mu is the constant, correct? Coefficient of friction, we call mu is the coefficient of friction. We vary from 0 to 1. When wheel is freely rotating, correct, then the 0. When wheel is stopped, that means 1. In between, depending on road surface, type of the road, correct, whether dry road, wet road, whether asphalt road, concrete road, or a compact soil road, already we saw. So that value you will, this one, depending upon mu will vary. Frictional constant. Lambda is given, and Fn is the normal force acting on the wheel. Correct? That is nothing. Fn is nothing but the weight, mass multiplied by G. Right? If I say that vehicle is 1000 kg, 4 wheels, individual wheel 250 kg. The M will become 250 multiplied by 9.81. That is the normal force acting. The I represent on individual wheel because I vary 1 to 4, the 4 tires. Correct? Now. So assuming that there's no.
Sir, what is lambda here?
Lambda. This is frictional constant. I will come back because they
Okay.
from one equation, this one. I'll come back. I will tell you next class. Thank you.
और पिछले का रिपोर्ट मिल गया अपने को
Okay. Assuming that there's no drag in the height of the road surface, it is a flat road. When you are applying brake, after the steering during braking up, you are not.
जो ड्राइंग इसके हिसाब से है बराबर ना
You are not steering the vehicle. The approximate static model for the load on each wheel can be approximated Fn. Normal force acting can be C11 but into M minus C2 into AX for the front wheel. For the back rear wheels, it is C11 into M plus this one. Where what C11, C12 are given here. C2. Correct? These three values are given. Because there's a complex derivation I am not taking. I took only the final equation. Correct? Final equation. The force acting on individual wheels, Fn. Because in this equation you have Fn. Correct? The Fn, how will you calculate? Mu you can find out. Mu also you should know. Depending upon road condition, also you take approximate value of mu. You are not going to measure mu vehicle is mu. Correct? We say that mu equal to 0.8 if it is a dry concrete road. Or 0.7 if it is asphalt dry road. If it is a wet, this one it may be 0.6. There are tables available. Correct? That is not, you can tell if how much water is there, all those things. If too much water is there, this value, this is I say the wet road, wet asphalt. Correct? This is 0.6. The thin layer of just what rain drizzled. No water is on the road surface. Just thin layer of water is there, just drizzle. Correct? It may be. But if already too much water is there, you cannot say that. Correct? All these values taken for a particular condition. In between it can vary. So the mu for this, then Fn can be calculated using this equation. You can see that front and rear wheel, there's a different formula where you can see that AX is the longitudinal acceleration of the wheel and LF is the distance between center of the CG point, correct, and the front wheel. I told you you have a chassis on which you have the right. So you have the back wheel. This is the front wheels. This is forward direction. This is CG point. COG or CG point on the vehicle. With respect to what is the distance? This distance and also this distance. That's what you are talking. LR, center of the rear wheel. This distance is called LR. This distance is called as LF. The height from the, what is the height from the ground level? Correct? The CG of 1 feet, 2 feet, center of the vehicle, COG point. Height of center of gravity. That is also placed as this one. Then G is the gravitation, which we know 9.81 meter per second square, meter per second square. We know that. Then once this is done, you can calculate C2, C12, C11, and you can substitute that in this, and you can calculate what is the force acting. Where M is the mass. Mass acting on individual wheel.
Sir, by using, sir,
Yeah.
sir, by using this derivation, any problem will come in examinations?
Any problem will come in?
Exam.
Any sum.
Any sum, sir. Any sum will come.
You have to take. You can express simple problems.
Okay.
It's not big derivation. I'm not giving you derivation. It's a big derivation. It comes 2 pages. That's why I give final equation. If the values are given, you are asked to find out what will be braking force. All these things you have to find out. Load
You will have to remember this equation, sir.
Excuse me?
Do we need to remember these equations, sir?
Yes, it is very simple. It's not big equation. Very simple.
I'll note the report.
Simple algebraic equation. Addition, subtraction, division. Nothing more than that.
Yes, okay.
Okay. So lambda is wheel slip. I will
Thank you, sir.
price wheel
Got
slip
that.
confirm tomorrow.
Got it. Thank you.
Individual wheel slip. That's the I varies 1 to 4. Okay. Long-tail coefficient of friction mu is proportional to velocity also wheel slip. Okay. Which is a non-linear function. And that's what is a wheel slip rate and changes with the different road condition. Correct. If it's a dry condition, wet condition, concrete road, asphalt road, or compacted muddy road, village road, correct? No, this one, not properly paved road, all this thing, friction with changes. Shall I go to the next slide?
Sir, one doubt. Sir, only one clarification required, sir. In this front wheel and rear wheel, during the braking event, vehicle mass transfer will happen. Usually, we need to add the mass front axle. In this equation, first is separation. Actually, it should be means addition.
Yeah, I thought this is simplified model
Okay, sir.
for understanding purpose.
Okay,
Full
sir.
model means you have to the mass transfer, all this is very complicated. This is
Okay.
to understand how the ABS works, approximately how it works.
Okay, sir. Got it, sir.
We call it simplified model.
Okay, sir.
Okay. Now, during this, lambda is nothing but wheel slip. I am correct. Okay. Okay. During braking, we need to maintain lambda within 5 to 15%. That is one of the important job of the ABS. Wheel slip increases, brake should be released. If wheel slip value exceeds beyond 50, you decided. Suppose you are the ABS designer for your company. You decided wheel slip should be between 5 to 15% for the vehicle what you are designing. Correct? If ABS will monitor wheel slip in this flow chart. Correct? That's what we said. If it is more than that, brake should be released. Correct? Current wheel slip is greater than S-max. S-max is 15%. Y company decided 20%. That means they apply brake for longer time. Correct? Brake will be applied for longer time, so the wheel speed reduces compared to more. The wheel speed reduces more compared to the vehicle speed. The wheel speed goes this one. When it becomes 20, brake is released. So the whole idea is ABS should see that the slip is between whatever the wheel slip you decided, 5 to 20 or 10 to 20 or 5 to 20, you decide. Correct? Within that, this one, wheel slip should be maintained. That's what we are talking here. So during braking, wheel should be maintained and the differential value of the wheel slip are also established. Please know that individual wheels we are talking. Wheel slip happens for individual wheel. Correct? One wheel may be on a dry road. Correct? Your vehicle is, for example, 2.5 meter, 2 meter wide. Correct? One wheel may be on a oily surface. In road, somebody spill little bit oil. From a truck when some oil leaked. One wheel is on this one. For example, right side front wheel. Correct? Left side wheel is not on the dry road. Correct? The right side wheel will start slipping. Correct? You have to calculate this slip, wheel slip you have to calculate. Correct? So, and apply braking force accordingly. If you apply same braking force, what will happen? Vehicle will be, rotate this one. Correct? Instead of going like this, correct? It will start rotating. All wheels are not unequal. Then you will have that. So that means the ABS has to apply braking force, not same force for different braking for different wheel, because it is measuring wheel slip. Wheel slip is indication whether what type of road it is. Yeah, any? I'm just seeing smiley places. Everybody is smiling. I want to know anything, especially from Arunachalam group.
Yes, sir. Some messages come through Teams, so to me, that is why everybody is pulling me. Everybody is sleeping.
Oh, okay. I thought
Disturbance, sir.
it is not this one, whether my explanation is not correct.
No, sir. Actually, someone is disturbing Arunachalam, sir. We connected from his PC. So be able to see the screen to all.
Lightest, I know. I am just lightest only because no, it's good.
Sir, don't take it. Sir, bad, sir.
Relaxly see the class is better, but too much is not relax. You should have a little bit this one relaxation, but same time this one. Fine. Fine. So that means
It's only disturbance from our side, sir.
yeah, no issue. That I just told you, lighter sensor, nothing wrong with it.
Right. Thank you, sir. Thank you for your
The
understanding.
wheel slip is I. So you have to compute for individual. I varies from 1 to 4. Correct? Individual wheel it calculates. Brake force is applied individually. Correct? That means this is slip rate. This is wheel slip. This is slip rate. You can see the lambda I dash. Correct? Slip rate you calculate. That can be finally equated. Slip rate can be calculated like this using this. Correct? Where W is the wheel slip, wheel speed, wheel radius. RW is here in this formula. RW is wheel radius. Correct? The W is the VW is the wheel speed. Correct? Then WA is the angular velocity of the each wheel, individual wheel. Again, as I said that again, finally will end up just like slip. Also, the frictional coefficient also depends upon type of the road. And also, please know that the frictional coefficient mu also varies with respect to slip rate, wheel slip rate. As the wheel slip rate increases, you can see that it is falling. Only it is good this region. Within this region, which is nothing but we can say that this is 10 and this may be 25 in this graph. Please know that every graph, something I say 5 to 15%, somebody says 10 to 15% the peaking. So this is the slip. You have to multiply by 100. Wheel slip is always 0 to 1 only. Similarly, the frictional comes to 0 to 1. Then the wheel slip is represented in percentage. So you multiply by 100. Correct? In previous graph, we showed 0 to 10%. Here it is 0 to 1. It is nothing but you have to multiply. Wheel slip, you have to maintain within, say, 0.05 to 0.2 something in this game. But anyhow, the frictional constant also, not only braking force. Braking force also, when the wheel slip is maintained within this only, you have to get the best. Correct? Then the frictional coefficient. See, braking depends upon frictional coefficients. Correct? You can finally will see that if you maintain a slip within this 5 to 20% by controlling the braking without locking, you get the best braking, smooth braking, correct, and also steerable. Suppose you apply brake, you see, suddenly somebody comes in front of me, because it happened to me many times. I told you, I used to drive. I never had driver. I drove my car more than 2 lakh kilometers. Correct? 2 cars I have, both cars together I have 2 lakh kilometers. Motorcycle 3 lakh kilometers. Correct? But I am in IIT staying in quarters. My office and quarters only for 1 kilometer. But other times I used to. Why I am saying this? I have come across many of the issues what I am talking. Correct? Somebody crossing when you highway. Correct? When you are going 80 kilometers, which is allowed, up to 100 kilometers you can go. 4-lane highway, Bangalore highway I was going. Suddenly one fellow was running. In median, you have they put the flowering plants to night time glaring, opposite put that is good. From that, one fellow jump and suddenly running. I applied brake. I didn't have that was Santa, no ABS, nothing. I saw something. Literally, they happened 2 or 3 times. One fellow was pulling a goat, suddenly jumping from goat in Hyderabad going, he was running across 50 to 70 meters only. Pure luck. Correct? Applied brake, few feet. Correct? Somehow. But that vehicle did not have Santro only, I'm talking, no ABS. Correct? So all these things are very important, safety related. Okay. When wheel slip condition is 0, wheel are same velocity, that means you are not applying brake. Correct? No brake condition. Correct? Wheel is locked, means the wheel is fully stopped. That means you are locked the wheel, but vehicle has a momentum, forward momentum. That is not good. Skidding happens. Right? So when vehicle is no steering, longitudinal steering is not possible. That means steering control is lost if wheel gets locked. Correct? Then small frictional force. When skidding happens, I told you, always note the rolling friction. That means tire is rotating. And in contact, they call rolling friction. Rolling friction is greater than the sliding friction. When wheel is locked, correct, there's a friction between tire and road surface. But wheel is not rotating. That is always lesser than rolling friction, at least 2 to 3 times sometimes. Correct? So, main advantage ABS is this.
Sir, one question. I'll not take much time. Sorry for that.
No, don't.
What is the Vx? Vx present here?
Yeah.
Means lambda equal to Vx minus Vwi. So what is Vx there?
Vehicle speed.
Okay, Vx is vehicle speed.
VW is wheel speed.
Wheel speed. Okay. Then lambda is the ratio. So it will be in percentage, this kind of thing.
Multiply by 100. Generally, give a number 0 to 1.
0 to
Lambda will come 0 to 1 only. See, now if you are not apply, this and this are same. Correct? Wheel speed, vehicle speed is same. Correct? What will happen?
Then becomes 0.
0. No slip. That means that's why you're dividing by Vx. Correct? So multiply by 100. This you will get 0 to 1 only. This value will get 0 to 1 only. But generally, wheel slip is measured, represented as a percentage. You multiply by 100. Slip. Just somebody has wheel slip 0 to 1 only. 1 means wheel is not rotating. 0 means wheel is rotating without brake. Then this vehicle speed, wheel speed are same. That means you are not applying brake.
Okay. And in the second equation, yeah, sorry for that.
No issue, no issue. Please.
Yeah. Then ax small ax represent acceleration or what?
This AX.
Yeah, correct.
Let me clarify tomorrow. I will give that.
Okay, no issue. Yeah.
See, anywhere if you see WI dash means it is acceleration. W is the velocity, angular velocity.
Angular velocity.
Angular velocity always with W, correct? Linear velocity we always say V. And if I put dash, this is acceleration. This is nothing but alpha. Angular acceleration generally they use alpha. Alpha equal W dash. Correct?
Yeah.
Linear acceleration A equal to V dash. Differentiate one, you will get acceleration. So integrate this, you will get V. If you integrate, you will get V. If you integrate this, you will get W.
Sir, in one of the previous equations, we have used AX for the vehicle acceleration, sir.
Correct.
Okay, yeah, thanks for clarification. Thank you.
Kind of.
Sir, one more doubt. The pump pressure will be constant with respect to vehicle speed, or based on the vehicle speed and based
You have
on
to constant
pressure will
and
be.
only braking force will be constant. That is Java, one of the Java ECU. That's why we said here you can see the monitors pressure. Do it this one, and also the pressure also will be measured. Pump monitoring. Here pressure also will be monitored. You want to have uniform force, no? If every time you have different pressure, please note that the pressure and the force are related. Higher the pressure in the hydraulic fluid, more force can be for the given area of the pressure applied. Right? Pressure applied area is fixed. If I want more force, you have to increase pressure. Higher the pressure, you will get for same area, you will get more force. Now, this one is the last slide. Please take it, very important. So here, this is brake pedal. You apply or release. Correct? Driver presses this one. Generally, this one hydraulic, this one there will be a booster valve which will be connected to master cylinder. Master cylinder will be you have the fuel. This one. This is the brake fluid reservoir. From here, pump sucks this one and pressurizes, and that is stored in this master cylinder. Here it is 1 bar. Right? Just to atmospheric pressure. From here, there's a motor. This is not so. This is controlled by ECU. It can be belt driven or electric motor, whatever it may be. Belt driven means there will be a clutch. Correct? Whenever you don't want this one, there will be a clutch will be there. Correct? So here the motor, electric motor can switch off. So this sucks the fluid from 1 bar. It presses, for example, 10 bar. 10 bar pressure. That fluid is accumulated here, stored here. Correct? So this is the inlet valve, main valve, A valve. We saw that previously, A. Correct? So this valve will be normally closed. This normally closed. Okay. This valve is outlet valve. Outlet means outlet from the, this is the wheel cylinder. The high pressure fluid will be sent through when the valve is open. This will go and will push this piston down. So brake pedal is pressed. This is the wheel, brake pedal is pressed. So wheel is getting stopped. Okay, that is done for few milliseconds. A valve open, again I say A valve open. During the time, the other valve, there are two valves. C valve is closed. Correct? So that means the pressure will go and act. Now A valve will open and this will close. The C valve will open. So the pressurized fluid here will return back here. From here, this is return. So the 10 bar fluid will up through valve will come on just become 1 bar during this period. Right? During this period, C valve is open. During that time, A valve is closed. When you want to apply brake, A valve is open, C valve is closed. You can see the C valve is closed. That means the fluid will go and act and it cannot come down. So these two valves are controlled by ABS controller. This is a control valve. How it will signal. This is a control signal. This is for A valve. This is for this C valve. You can say 180 out of phase. Correct? When this is open, this is closed. When this is open, this is closed. So this is called a modulating frequency. The number of pulses sent will be 1200 per minute. Sometimes even 2000 also. 2000 pulses per minute. Number of pulses per second divided by 60. Correct? But another one also said this pulse is called as PWM, they call it.
Speak loud.
Pulse with modulation. Yeah.
Sir, there will not be any relief valve in the system.
Pardon, madam?
Answer.
Please tell me.
Just ask once.
There will not be any relief valve in the system.
Feedback.
A relief valve, sir, relief valve.
Sir, I think he's asking about a relief valve, which is mentioned is outlet valve.
Yeah. Yeah. So see, if the fluid, see, for example, no, here it is 1 bar, pump pressure 10 bar, and it is waiting. When this valve is open, this valve is closed. When during this time, you can see that this time, this valve is open. The high pressure fluid goes and pushes this piston down, and the brake pedal applies, touches. Braking force is there during this time. Correct? That time this valve should be closed. Otherwise, it will leak.
The pump will be continuously running, or it will only switch on when the braking is required.
When see, when brake is over, this valve will be completely open. When,
Okay, sir.
so that means the brake will be released. Once the vehicle comes to
Sir,
stop,
but if the inlet valve is closed, you said that inlet valve will be closed in case of pump will in case of braking is not required. So that time,
this valve is closed today. So the pressurized fluid will be stored here. So
okay. So that time fluid will from where it will flow. So these two
Actually-
other valve it is going. So means further it is used somewhere.
Yes, actually, add on to sir.
Fluid from here will be released and stored here. This line will not have any fluid at all. When no braking condition, when vehicle normal running, here there's no fluid at all. The fluid will be drained to the reservoir because this valve is open. When normal operation, this valve is open. When you operate the ABS, that time only this things happens.
Yes, sir. And then this pump will be continuously running, sir, or how?
No, whenever need. See, if this pressure reduces, this pump will run whenever this pressure reduces. They have to maintain 10 bar pressure. There's a reservoir. I already told you, And yesterday I told you there's a reservoir will be there.
Aditya, actually, add on to sir point is actually there are two circuit. One is normal braking event that will be from mass sprinter reservoir. This particular circuit, when the ABS intervention is coming, that time only the motor will come on the picture. It will continuously run. The inlet valve and outlet valve, it will monitor the wheel speed. Whenever we are detecting the slip, that time the relief valve will open. The circuit, the 10 bar pressure will get reduced to somewhat close to zero. It will not zero, it will come down. And when his wheel is become stable, then it will release 1 second. It is millisecond, it's going apply, release, apply, release.
Yeah, thank you. That's what is shown in this picture. You can see here.
Yes.
Again, one more thing I want to tell you, this is pulse width modulation. Like the width, this is on duration. You can see initially, this is for example 10 milliseconds, this duration. Now you can see it becomes 7 milliseconds. Then it becomes 5 milliseconds. Correct? Already vehicle speed is coming. Finally, says that it will apply very smooth, but already vehicle speed is reduced. Then stops.
Okay, sir. Okay, sir. Thank you, sir. Thank you so much.
Okay, very good. Thank you. So that's it. This ABS over. I stop here. Your exam ABS.
Sir, just one last query.
Tomorrow, one more class is there. Sorry, forgot. That person will there. We'll talk about cruise control.
One last query. Can I just ask?
Definitely, please.
Sir, there is this myth that ABS works well only for a particular duration, right? In lifetime basis, I'm telling. Only for say it'll be efficient in a vehicle for only like say 50 times, something like that. After which ABS is not that efficient or something. Is that true, or ABS actually can work for a very long lifetime?
See how you maintain, no, because it is like a tire. See, for example, normal brake itself, no. Correct. There's a wear and tear, all those things. If you maintain properly, it will work. That is nothing like within this time only. See, if normal brake itself, you don't change the brake shoes. Correct. Brake shoes become thinner. Correct. Then the performance will not be good. Can see brake itself is connected with the tire also. If your tire become harder. Correct. Initially, tire will be very this one no soft. After 10,000 kilometers, because getting heated up, all those things, what will happen? The tire will become stiffer.
Understood, sir. Service condition of tire comes into play.
All those things matter. Even the ABS system maintain how good you are maintaining all the parts. Correct. That they also get wear and tear, all those things. We'll stop here. But tomorrow we have class. Sorry, tomorrow we will start new topic. Correct. About what you call cruise control. That is now, till now, we know autonomous vehicle, also introduction, all these things.
Till tomorrow.
Programming, putting the magnets on road, all those things. Please remember that the portion will be from day one what I taught. Maybe introduction, how the initial path program, this one, write about that, basic things, correct? Introduction, this one. Then we talked about different type of automation, SAE level of automation, all those things, correct? So introduction, see, you are going to get questions for around 30 marks, right? Around 30 marks will be for your midsem exam. Then we talked about steering control, electronic steering, steer by wire. Then we talked about engine, fuel injection system, CRD engine, how CRD engine controller also controls the particulate filter, all this thing we talked. Making electronically control engine, electronically control steering system, electronically control braking system. Without that, no autonomous vehicle. Correct? Each and every main thing is accelerating, decelerating, steering left or right, or stop. You want to stop the vehicle.
Sir, one thing I want to clarify is in the classes of autonomous vehicle introduction, it was told that achieving the level 5 automation, which is completely autonomous car,
okay,
where the human intervention is not required at all.
Okay.
They will drive the path based on the whatever algorithm and sensor they are using.
Okay.
So that is one level. Before that, if we want to have the autonomous level of 4, then geofence will be required, so that it will guided path will be required in that way, right, sir?
Yes,
And
yes,
since
yes.
since that is very costly affair, and that has some environmental challenges, many challenges are there. So the forward path for the autonomous vehicle is to adapt system by system, once like a cruise system, FI system, and steer by wire, steer by brake by
This thing
steer.
already come.
So these things are basically path to autonomous vehicle, right,
That's
sir?
what I'm saying. That's why no, this thing already happened in Western country.
I agree.
In Europe, correct, Sweden, many of the, I told you, my classmate who did study together, 1982 or 84, who worked in IIT along with me for 10 years. Then he left to US, worked in a company called Navtech, Navigational Tech. Google Map has acquired that company. Google has acquired that company called Navtech. It was a Chicago company. I'm talking 1980s and 90s. My friend, my own classmate worked with the Navtech for 12 years. Now he's working with, he worked with Continental, correct, a tire company, which also works autonomous vehicle. You know that everybody wanted to work in autonomous vehicle. Tire company wanted to work. Google is a internet company wanted to work. Regular car company wanted to work. That is the future. I asked him, just I told you the first class result. He came 2 months before in Chennai for 2 days. I had an extensive discussion with him. He said, within another 5 to 10 years in US roads, you will see more autonomous vehicles. Government is also making see that want to reduce number of accidents. Many of the accidents, they see that including insurance companies, car companies, government, regular, everybody is pushing towards autonomous vehicle. They say, especially Western Europe, that means what we are talking about, Germany, Italy, France, UK, all these things, Sweden, Belgium, all these places, and also in Australia and Japan and US. It will maximum within another 5 to 10 years, you will definitely see autonomous vehicle, more vehicles. Maybe close to 5. So much fun. Till now, the car company was that. What I heard is car company was not interested in showing, except Google, Tesla, this company. Now car company realize that they cannot see, they don't pump money unless there's a profit. Automobile company already whatever they made research, they want to make money. See, I'm not talking about it because I'm just like you only, but I'm getting feedback from discussed conferences, all those things. People, so the big this one happens only when automobile company enters. It is a autonomous car, autonomous bus. Correct? Who has money? Automobile companies, $1 trillion, correct, worldwide. They resist. No, they want to make money out of whatever they invested. They don't want to go to new technology. Why you have to invest? I try to make money out of what already invested. Lot of resistance. But that resistance was broken by Tesla and Google. Correct? There's a private now. See, main problem is, again I'll tell you, starting a new car company. For example, tomorrow you start, you need around 3,000 to 5,000 crores. Start a small company at 10,000 crores investment. But electric car company doesn't need that much investment to start electric motorcycle. You know, the private people are making small startups, electric motor competing with regular two-wheelers. I know one company called Airtel. I know the student. All the students I know, they're from IIT Madras just 10 years before they completed BTech.
Airtel is a very well-established company, sir. It's a very good company.
Correct? They're competing with TVS, Bajaj. Can you think about that? Because electric vehicles, you don't need that much money for investment. But if you want to do regular IC engine base, you need a huge investment. Correct? So, because other people are resting, that's why Tesla has taken a path, go electric. Correct? Otherwise, they need to build a vehicle, IC engine based vehicle, prove it. After that, that itself takes huge money. That is why now everybody going to electric autonomous vehicle, they want to go to through autonomous electric vehicle too, not IC engine based. Investment can be less. That's what I hear, because this not, I'm just one teacher. I'm monitoring what is happening around the world as a teacher. I want to give the latest information to my students. I talked to this one. He said that maximum another 5 to 10 years, definitely autonomous vehicle, you can see at least 20 to 30% vehicle in US within 10 years. But government is pushing so hard. But it may be most of the vehicle may be electric or hybrid vehicle. So again, fuel consumption, all those things, emission regulation, all those things. Okay, anyhow, we'll see you tomorrow 5 o'clock. Thank you. So
Thank you,
tomorrow will continue. Then the portion will be what I cover tomorrow. Tomorrow I'm going to cover what is the police control. Up to that, the portion for your exam.
Okay, sir.
Thank you, sir.
Thank you, sir.
Kind of
Thank you, sir.
tomorrow. Bye.
Thank you, sir. Thank you so much.